Okay, we are going to solve a quadratic inequality. This is problem number 43 from page 154. We're going to write the solution set in interval notation, and I'm going to use the critical point method. If you're going to use the critical point method, you need to make sure you have less than or equal to 0, not less than or equal to -3. So let's go ahead and add 3 to both sides. And then for this problem in particular, it's kind of more complicated because we have a negative in front of the x squared. So I think at this point it would be nice to multiply both sides of the inequality by -1 so that we can simplify the left. Just remember, if you multiply an inequality by plus or minus, or excuse me, by a negative, you need to reverse the inequality. So instead of less than, it's going to be greater than. If you didn't realize you needed to do that step and you did this problem and ended up getting a wrong answer, it was probably just based on that negative error. Okay, so here we have this inequality and we're going to find the critical points. The critical points are the points that make it equal to 0 rather than greater than 0 or less than 0. What makes it equal to 0? So set your expression equal to 0. If it factors, that's great. If not, you can use the quadratic formula. Set each factor equal to 0 and solve. And you have the critical points. Why do you need the critical points? Because you're going to use those to divide the number line into intervals. You can draw a number line if you'd like, such as, let's see, we're starting at -infinity and we're going to infinity. And we have a break at -3 and a break at -1. You break the number line or you split the number line where you have your critical points. So that means we have the intervals -infinity to -3, -3 to -1, and -1 to infinity. Those are the intervals. What we do with those is we pick a number in each interval and we test it to see if we end up with a positive or a negative. So test a number from each interval. Okay, so looking at the first interval, you can pick whatever you want that falls between -infinity and -3. I'm going to choose -4. Here I'm going to choose -2, and here I'm going to choose 0. Now, where do you test it? You test a number from each interval. Test into the factors. So let's go back and find the factors. If we look back at where we were factoring to find our critical points, those are the factors. That's where our test number gets plugged in. So we take our first test number, which was -4, plug it in here, -4 plus 3, that is negative. It doesn't matter what the number is, what matters is if it's negative or positive. And then -4 plugged into the other factor, -4 plus 1, that is also negative. So we have negative times negative is positive. Then we move on to the second factor, or the second test number, -2. Plug it in here, -2 plus 3 is positive. And in here, -2 plus 1 is negative. Positive times negative is negative. And then our third test number, 0, we get positive times positive. After that, what we need to do is analyze the results, draw a conclusion, answer the question. So we need to go back and see what we were being asked. Looking back up here, we see that we were trying to figure out what makes this expression less than or equal to 0. Oh, but we changed it. So not that one, this one. What makes this expression greater than or equal to 0? And since we were looking for greater than 0, we want the positives. If you were looking for less than 0, you would want the negatives. So we have a positive here and we have a positive here. That means we want this interval here, and we want this interval here. Now what about the equal to 0 part? It was greater than or equal to 0. That means we want to include the numbers that made it equal 0. We want to include the number -3 and include the number -1 in our answer. So we're going to say x is an element of the interval from -infinity to -3, and the way we show we're including it is we put a square bracket around it, or, union sign for or, the interval from -1 to infinity, square bracket around the -1 to indicate we're including it. That's what our answer looks like in interval notation. If instead you're writing your answer in set notation, it will look like this. Let's see. This interval is the same as saying that x is less than or equal to -3. And you can use the word or use the union symbol again. And this interval is the same as saying x is greater than or equal to -1. So these answers are equivalent. This was interval notation, which is what we were asked for. The other is set notation. And one last thing is I would like to make a graphical connection so that you can see a different way this problem could be solved, or just kind of a way to check for reasonableness. So if we go back to our expression, x squared plus 4x plus 3, and we make that into a quadratic function, f of x equals x squared plus 4x plus 3, we know that's a parabola. We know it opens up because the leading coefficient is positive. And we know it has a y-intercept of the 0, 3. So that looks something like roughly this. We also happen to know from the previous work we did that there's an x-intercept at -3 and an x-intercept at -1. Well, look at the behavior of this parabola. Because it was opening up, we have a section that has positive y values, another section that has positive y values, and a section that has negative y values. It goes positive, negative, positive, just like we saw when we did the critical point method and we tested numbers into intervals. We had positive, negative, positive. So these are telling us the same thing. This is a good validation of what we saw algebraically.